So let's see about the amplitude. So amplitude is rising setting azimuth or the bearing of the celestial body when it is on the rational horizon. So let's see in this rational horizon diagram. So this is the Earth and this is the celestial sphere. Earth is rotating west to east about its axis. This is east and this is west. So we can imagine that there is a celestial sphere of radius infinity and it is going to rotate from east to west. Earth rotates west to east, so apparent motion of the celestial sphere is rotating from east to west in the opposite direction. And this is north and south celestial poles, and this is the celestial sphere is going to rotate from east to west. So all celestial bodies rise in the east and set in the west. Now let's see the tilt of the Earth. Earth is tilted 23 and a half degrees from the vertical. So how to determine vertical and for that let's see horizontal. So center of the sun and the center of the earth, if you join in the same plane, that is plane of ecliptic, and all the planets except Pluto, they lie in the same plane of ecliptic, that is our horizontal, and 90 degrees to the horizontal is the vertical. So plane of the ecliptic and earth's axis have approximate angle of 66.5 degrees. Now let's talk about the celestial sphere. So as the ecliptic, you can see is 23 and a half degrees from the Earth's equinoxium. So this is the annual sun motion in this ecliptic motion. And this is the annual motion of this sun. Suppose sun will appear to move. So if it is so in a particular month, sun will appear to move like this. So if you have an observer here, this is the point above the observer is zenith and 180 degree away is nadir. So zenith and nadir are 180 degree apart, and we have a great circle, rational horizon, passing through the center of the earth, and all the points are 90 degree away from the zenith. And we have north and south celestial pole also. And same situation when it is turned, when zenith is up. So this is your prime vertical. Vertical, prime vertical means the vertical or the great circle which is passing through the north celestial pole and south celestial pole. So we are so these are the rational horizon diagram. This rational horizon is a great circle, and we put this rational horizon here. Then there will be 2 points. One here it is north and south, towards north and towards south, and east and west. So these points we make here north, south, east, and west. And observer is at the center. This is the rational horizon. So this is your equinoctial diagram, and this is your rational horizon diagram. And this equator and the projection of the equator is called equinoctial. Equinoctial is represented at the arc. So this is the equinoctial red arc, WQE. QZ is your latitude, and since body is north of equator, so it is north latitude, and equator to pole is 90 degrees. So since north pole is visible in there, and this is called elevated pole, and south celestial pole is not visible, so this is called south celestial pole is depressed pole. So now when we introduce the sun is rising, the sun has to be on the rational horizon. So in this diagram, you can represent the sun on the rational horizon here, and sun is going to set, rising from the east, setting on the west. And this is the annual motion. Annually, sun can be on the north also, and in 24 hours, sun will move like this. It's not a annual motion. So sun is rising in the east, rise up to the meridian, and then set on the west, rational horizon. So we have this PZX triangle, quadrantal triangle, which means that one side is 90-degree. So in PZX triangle Napier rule, we need to have one angle 90-degree. So each part of this circle is representing 90-degree at zenith. So in PZX is a spherical triangle. In this spherical triangle, angle PZX, this angle PZX, rising setting azimuth. So this is the azimuth of the sun, of the rising sun, because it's on the east. And NZ is your principal vertical, because the prime vertical or principal vertical is the vertical passing through the north and south celestial pole. So the definition of amplitude we already seen before, that it's the arc of rational horizon at zenith measured from the principal vertical circle and the vertical circle passing through the celestial body. When it is rising or setting, so this is the principal vertical circle, north south vertical circle, the vertical circle passing through the body. So this is rising angle, and if declination is south, so rising setting prefix is given as per the rising setting, that is prefix is given as per the declination, and suffix as east or west, that is rising or setting. So as you can see here, declination is north and rising, so azimuth will be east and north, in the first quadrant northeast. If it is south declination, so southeast. So prime vertical is passing to east west, this is east west. So amplitude we measure from the prime vertical circle, so this is the angle. So azimuth is measured from the north south angle, and amplitude is measured from the east west. That is how much the vessel body is angled from east and west while rising or setting. So if the body is not, if amplitude is zero, but body is on the east-west vertical circle. So rising azimuth is 90 minus amplitude, or amplitude is 90 degree minus rising setting azimuth. Now to solve this PZX or Napier triangle or amplitude and azimuth problems, we have Zx is equals to 90 degree, because distance from the Z to X is all 90 degrees, and we have adjacent angles, that is Z and X, and adjacent sides PZ and PX, and then opposite side, opposite angle P. Sine of middle part is equal to product of opposite cosine of opposite parts. 90 minus P is equal to cos Z into cos 90 minus PZ is equal to cos Z is equals to P to Q is 90 degree. So PZ is latitude is 90 minus PZ. So 90 minus PZ is your latitude. So cos of latitude, and Z, and what is PX? PX is 90 degree. So declination is 90 minus px. Is from equator to x is declination, and this is px. And p to equator is 90 degrees. So px is your polar distance, and 90 minus px is your declination. And z, or angle z, is your azimuth. So sine 90 minus px is your sine declination, is equals to cos z into cos of latitude. So cos z is equals to sine declination upon cos latitude. That is your amplitude or azimuth, rising setting azimuth is used in this form. So amplitude is 90 minus rising. So sine of amplitude is equals to cos z or cos azimuth. So sine amplitude is equals to sine of declination upon cos of latitude. So this is how we determine the formula of amplitude. Now from traverse table, how to use this? So amplitude we can take out if you have the declination and the latitude. What will be the amplitude? So declination is 6 degrees and latitude is 10 degree. So amplitude is 6.1 degrees. And naming, it will be as per the rising and setting. Rising east, setting west, and declination north, and declination south. Name is south. So amplitude, in amplitude, prefix is east west and suffix is north south, and in azimuth prefix is north south, suffix is east west, like normal cardinal system. And for azimuth tables, it's like this, also similar. So let's see one example. We have dr latitude 40 degree north, longitude 150 degrees east, and 17 January. Rising sun bore 120 degrees compass, variation 5 degrees west. Deviation we have to find out from the chart and this thing. So we have the almanac of 17th January, and sunrise time is given for our latitude 40 degrees 720. So we write the LMT of sunrise 17th 720 00 January, and so LIT to calculate GMT 150 degrees divide by 15, so 10 hours, and then GMT we get light longitude is GMT least, so we subtract from this 10 hours. So we get 16 on 16th of January, 21 hours, 20 minutes is our GMT. Then we calculate the declination of the sun on this GMT time. So declination has always calculated from GMT time. You can see here UT, it's GMT. So 16th, 21 hours, you have 147, 33.8 is a GHA. And for amplitude, we don't need, but if later on you will need. And for declination, south 20 degrees, 55.7 is our declination. So we write the declination and then we need to take D correction. So you have D 0.5, and if you examine, declination is reducing or decreasing. That means we choose minus sign, and you see the D correction from the increment table, and we have for 20 minutes, 20 minutes. So for 20 minutes and 0.5, D correction is 0.2. So 0.2. So declination is 20 degrees 55.5 south. Now we put in the formula. Cos rising setting azimuth is equals to sine declination upon cos latitude is this, and naming cardinal system. So declination is south and rising, so east. So southeast. So through azimuth we convert. So south east is this angle 62. So 180 minus 62 for 3 degree cardinal notation. 180 minus 62.2 is 117.8 degrees true. So compass azimuth is given 120 degrees true. So compass error is 2.2 degrees west, and we have the variation. So deviation plus variation is compass error. So our deviation is 2.8 degrees east. That's what the answer we needed to find out. So we can make this a rational horizon diagram, putting the east, west, north, south, zenith, equator, our latitude, and the body, and the angle azimuth 62.2. We get the answer.